Okay, now that we've done some simple applications, I want to do some more involved examples. These are done slightly differently in the book, and you're welcome to do the way the book does them. I would recommend you do them the way I do them just because I think that you'll actually use it in your real life if you do. The way the book does them, you'd have to pull out a piece of paper in the middle of a store and to figure out what the new price of some sale item would be. With my way, you can do it in one step on your phone. So there is an advantage, but I just want to, I guess, let you know that there is a difference between this lecture and the book. Okay, first of all, how do you write the decimal equivalent of 100%? Okay, if I take off the percent sign, I have to divide by 100, so I just have 1. So the decimal equivalent of 100% is 1. Okay, let's look at another problem. If you buy a $40 pair of shoes and the tax is 6%, what is your total? Well, I know the tax is 6% of 40. I'm just filling in the blanks on that sentence. Tax is 6% of 40. So that means tax is T equals 0.06, converting 6% to its decimal form. Percent of means multiply, so times 40. I get 2.4. So my total would be $40 because I have to pay for the shoes, plus $2.40 because I have to pay the government the tax, so I have $42.40. Now here is a separate question, perhaps related, perhaps not. What is 106% of 40? Well, 106, what is, that's x equals, 106%. Take off the percent sign, convert to a decimal, move the decimal point 2 places to the left. That makes it 1.06 times 40, and I get 42.4. Now, do you notice anything? Why did I have the same answer? Up top, I just had 6%. I didn't have 106% of anything. And down below, I had 106%. Why are they the same? Notice, if you pay 6% in tax, you're paying a total of 106% of the price. You pay 100% of the shoes to the store and 6% of the shoes to the government. So all in all, you pay 106% of the price. This is what I mean by an add. So let's say, here is a separate example. If everything in the Mac store is 15% off, yeah, right, I wish. How much would an iPod Shuffle be that normally retails for $60? Okay, let's look at it this way. The discount is 15% of 60. Notice I've just filled in the blanks on that sentence that I have you do in Lecture 7C. Discount is 15% of 60. That makes sense in English, right? Okay, translating it to math, the discount is D equals 15%, changed 15% to 0.15. Percent of means multiply, so I have times 60. So the discount is $9, so my sale price would be $60 minus $9, which would be $51. That's absolutely 100% correct, but I'll bet that there are about 1% of you that would actually pull out a piece of paper and figure that out in the Mac store. You'd probably just take it to the cash register and take their word for it that they were charging you the right price. Let me show you how to do it all in one step. What is 85% of 60? Well, what is x equals 85%, 0.85, percent of means multiply, so I multiply by 60. That's 51. Why are those the same? This one's a little harder to see. Look at it for a minute. Why do those have the same answer? So if the Mac store is taking 15% off of a price, how much is left? If they take away 15%, then only 85% is left. 100 minus 15 is 85. So if the shuffle is 15% off, you pay 85% of the price. So here are the formula. If P is increased by R, I take 1 plus R. So if I'm increasing, that's adding sales tax, adding a shipping cost that's a percentage. If I'm increasing the price by a percentage, I just multiply that price by 1 plus R. If I'm decreasing the price by a percentage, that sale price is 20% off, 50% off. What if everything in a store is 80% off? I take 1 minus R. So R is the percent increase or the percent decrease. So let's say that we buy a chair online for $350 and we have to pay 20% for shipping. We're assuming there's no tax because it's online. At least there's no tax in 2012 when I recorded this. But we just want the total price. Okay, let's look at the same thing we've got here. Blank is blank percent of blank, and I want you to pay very close attention to this. My total cost is what percent of the chair price? My total cost is 120% of $350. I want you to make sure that makes sense. I have to pay 100% to pay for the chair, and I have to pay 20% to pay for shipping, so I'm paying 120%. So that means my total is 1.20. Change your percentage to a decimal. Percent of means multiply, so I multiply by 350, so it's $420. My total is $420. Okay, you donate 27% of your paycheck to charity. Your paycheck was for $590. How much do you keep? So my keep percentage it wouldn't be 27%. 27% is what I give away. If I give away 27%, what percent do I keep? I keep 73% of $590. Yes, you could absolutely find what you donate and subtract it. That will work. That's absolutely fine. I just want to show you a different way. So the keep percentage is 73% of $590. Keep equals 0.73 times $590. So I keep $430.70. Does that seem about right? If you're keeping like $700, then you've done something wrong because you can't keep more than you make. So just make sure that it seems right. So, and again, you could just find your donation by taking 27.27 times 590 and then subtracting it. So these problems are not hard to do the other way, but some other problems are. So let me just show you coming up. Your roommate lost 7% of her body weight. She now weighs 135 pounds. What did her weight used to be? Okay, look at this model. Blank is blank percent of blank. So if the first blank is her new weight is what percent of her old weight? Think about that. She lost 7%, so her new weight is 93% of her old weight. It's a discount. We're discounting her old weight. Her new weight is 93% of her old weight. So 135 is 93% of her old weight. So we have 135 equals 0.93x. So x equals 145.16. So her old weight was 145 pounds. How many of you were tempted to just take 7% of 135 and add it back to find her old weight? That you can't do. In other words, if you said the old weight is 135 plus 0.07 times 135, it looks like you're pretty close. But it's not right. This is more than just a rounding error. This is a fundamental, this is a really, really big mistake. Let me see if I can explain why a little bit better. I'll try to explain why adding 7% of her new weight is different from taking off 7% of her old weight. Just so we have easy numbers, let's say that there's a $100 sweater that you really like, and it just got marked down 20%. So 20% of $100 is $20, so the new price is $80. That's easy math. Now let's say that you forgot the original price. Let's say that we forgot the old weight of the roommate or whatever. We only remember that you paid $80 and that you got 20% off. Well, if you said that you wanted to add back 20% of 80, what do we get? 10% of 80 is 8, so 20% of 80 is 16. If we add it back, we get $80 plus $16. That's only $96. It's not $100. Taking a percent off is very different from adding a percent to. So you need to pay very close attention to what you're taking the percent of. In the slide before, we were looking at a percentage of her old weight, not of her new weight, of her old weight. So whatever we take the percent of has to be of the old weight. Okay, there is another problem to do this. There is another way to do this problem, and this is the way that the book would do it. So I'll show you the book's way, and hopefully you'll see why I like my way better. This is our way. This is the way that we did it on 2 slides ago. This is the book's way. Let x equal the old weight. The new weight would be x minus 0.07 of x. That would be the old weight minus 7% of the old weight. So you'd have 135 equals x minus 0.07x, which is 0.93x, which is 145.16. So this is actually the same thing as what we did, but we just kind of did the work up front and by finding that 93%, doing a little bit of thinking and finding that 93% first. Okay, we got a 3% raise. Your normal paycheck is $165. What will your new paycheck be? Doing it the long way, you'd say my new paycheck is my old paycheck plus 3% of my old paycheck. My new way, so my new paycheck is $169.95. Here's the way I recommend. New paycheck is 103% of my old paycheck. Do you see why that phrase makes sense? The new is 103% of the old. If the new is increased by 3%, it's 103% of what it used to be. So we just have the new is 1.03 times 165, and we're done in one step. That's a problem you could just do when you're sitting in a store or wherever you are on your phone without pulling out a piece of paper. Okay, those are discounts and adds, and next we will do the very last thing for this lecture, which is simple interest.